Hello, good afternoon, everyone. We'll start the class within a few minutes. We'll start this session. So, yeah, I hope you all remember yesterday we were talking about DSA in AI. So, yesterday we have just seen what is DSA, data structures and algorithms. Today we will again look at them and also DSA in AI. How is that used in AI? So yeah, let's start this. I'll share my screen. Yes, I hope my screen is visible. Am I clear? Please react if you guys can see the screen. Okay, fine. I hope you are all okay with this. We have looked through all of these yesterday. What a data structure is and what an algorithm is. So let me quickly rewind this. So what is a data structure? It is a method of collecting and organizing the data such that it becomes easy for us to perform any kind of modifications, changes, or operations to that data. Okay, so this is nothing but a data structure. So data structures uh, are used to store order data. So in the data structures, we store ordered data rather than unordered data. We store ordered data. Various operations can be performed easily. So a data structure should be designed such that it reduces the complexity and increase the efficiency of the data. And I hope everyone's clear about this. We have looked through characteristics and need for data structures and all of this. So coming to an algorithm is a step-by-step process, and it defines a set of instructions that are to be executed so that we obtain the desired output. Okay, it is just a step-by-step process that contains some instructions, uh, which are essential to get our desired output. Okay, so here it might be of any language. I hope I'm clear. We have seen all of this yesterday. So again, in programming terms, algorithm is a set of well-defined instructions that are used to solve a problem. It takes some set of inputs and then gives output. Yeah, okay. This is all about that. We have stopped yesterday till here, I guess. Yeah. Yeah, so coming to types of data structures, everyone's aware of this, I guess. We have several types of data structures. So, primarily, they are divided into two types. They are linear data structure and non-linear data structures. So, what is a linear data structure? In linear data structures, elements are arranged in a sequence, like one after the another element. Since elements are arranged by order, so as they are orderly arranged, they are easy to implement. Linear data structure is easy to implement. Why? Because it is sequential. Like all the what elements in an data structure are arranged in a sequence. So also when the program complexity increases, like when it contains too much code, or when the program is too complex, these might not work. So we have to choose another type, that is non-linear type, whenever there occurs complexity. So what are the types of linear data structure? So even under linear and non-linear data structure, we have other subsections among them. So coming to linear data structure, we have again several types. So we'll look into them. So first we have array data structure. Yesterday we have just gone through what are several types. I hope everyone's aware of that. So first is array data structure, and then stack data structure, queue data structure, queue and stack linked list arrays. I hope everyone's aware of these. Yeah, so we have four types in linear data structures. Okay, coming to array data structure. First one is array data structure. So everyone might have an idea how an array looks. How do we represent an array? So what happens in an array? The elements are arranged in continuous memory. So what did we just learn about what a linear data structure is? The elements are arranged in a sequential order. As you can see here, they are arranged in a sequence. Elements in memory are arranged in continuous memory. Like all the elements of an array are of same type. Like in array, we have all the elements as of same type. Like this is a natural number and a whole number, and we do not have any floating number here. This is an integer and this is an integer. All of these are integers. We don't have any characters or floating numbers, decimal numbers that are we don't have any decimal numbers or characters here, right? We only have integers. So we can tell that it contains elements of same type. And the type of elements that can be stored in form of arrays, it is determined by programming language. So how do you retrieve an an array? Array contains indexes, like it gives index numbers to all the elements in the array. Like the indexing starts from 0 and it numbers them sequentially. This is all about array data structure. I hope everyone's following. Yeah. Okay. And then the second type of linear data structure is stack data structure. So what is stack? Stack is yet another type of data structures that is widely used. So here the elements are stored using LIFO principle. I hope everyone's gone through LIFO and FIFO. So LIFO is nothing but last in, first out. So see, as you can see, the number that is last in. Okay, this is a stack, and the number that has got in last. Like first we have added 1 to the stack, and then 2 to the stack, and lastly we have added 3 to the stack. So what does that mean? Last in. So 3 is the element that was in in the last. Okay, so this last in element will be the element that will be first out, like last in, first out principle. So here the 3 element was added in the last, and now here while removing we have operations that can be performed to stack and queue. So 3 will be removed first. So the element which is let in first will be out first. That is the operation that leaf that stack performs. Okay, it follows this principle. Okay, that is the last element stored in a stack will be removed first. So whenever you look at stack, you can understand that it follows leaf of principle. It just works like a pile of plates where the last plate kept on the pile will be removed first. So you can take an example whenever you go to dinner or visit a function. What happens in a pile of plates? The plate that is kept in the last will be taken first. Simple. It is as simple as that. You guys have a look at it. I'll show you for a minute or two. You can have a look at it. Yes, I hope everyone has gone through them. Let us now continue with further things. So after stack data structure, we have queue data structure. So what happens in queue? Unlike stack, queue data structure works with the FIFO principle. So while talking about stack, we dealt with LIFO principle, right? Whereas for queue, it will follow FIFO principle. Like what happens here is the element that is uh, let in first will be out first. Like where the first element stored in the queue will be removed first. It works just like a queue of people in a ticket counter where the first person on the queue will get the ticket first. So what happens? Take an example of wherever you stand, like while boarding bus, you stand in a queue. The person who is first in the queue will board the bus first, and he'll get down first. This ticket example, this is also an example where the person who entered first to buy a ticket will leave first. So here we can also perform add and remove operations. That's it about queue. And then the last type of linear data structure is linked list. I hope everyone's aware of what a linked list is. So it contains two nodes, like see here. In a linked list data structure, data elements are connected through a series of nodes, and each node contains the data items and corresponding address to the next node. So we have uh, two two nodes here, like within a linked list contains of two nodes, where the first element, like the header, it contains the address of the next list, or address of the next node, whereas the tail contains data item. So this is how a linked list looks like. So also in in linked list, we have several types. Uh, See this for a minute. I'll tell you various examples and various types of linked list. Yeah. So what happens here? Unlike arrays, what happens in arrays? The elements are stored contiguously. But coming to a linked list, unlike arrays, the elements are not stored in contiguous memory locations. Instead, they use uh, these links where they are linked using pointers. So this is known as a pointer, and two nodes are connected using this pointer. So what happens? This is a data. This like header part stores data or a value, and then this part, that is tail part, what does it store? The address of the next node. So what happens? This contains the actual information. This is the element that the node holds, and then The next point refers to the memory address of the next node in the sequence. Like in the sequence, the next node. So in the case of last node, generally, it is pointed as null. So I hope everyone's clear with this. This contains actual information or actual data, and this part of the node, that is tail part, it contains the address of next node. So under linked list, we have singly linked list, we have doubly linked list. So what happens in a single linked list? This is a single linked list. In double linked list, we also have another pointer that is pointing like this node, two node will be pointing to first node. Also in reverse direction, we will have pointers. That is all about doubly linked list. We also have circular linked list, like everything is connected to each other. This last node will be connected to first node, that and first will be connected to last. This is all about circular linked list. So linked list data structure. This is all about linked list data structure. I hope everyone's okay with this. Are everyone following, or you have any issues? Yeah, so okay. You can have a look at it for some time and then we'll continue. Okay, fine. So under nonlinear data structures, we have again several types. I hope yesterday we have talked about this. Under nonlinear data structure, we have graph data structure, tree data structure, and wait, yeah. Uh, we have these two. We also have heap and other types. They have not mentioned about that, but it's okay. We'll look into them. Yeah, okay, we'll look into that. Yeah, so coming to non-linear data structure, we have graph and tree data structure. So, unlike linear data structures, elements in non-linear data structure are not in any sequence. Like, if you can see here, we do not have any sequence here. Instead, they are arranged in a hierarchical structures, where one element will be connected to one or sorry, where an element will be connected to one or more elements. So instead of sequential order, it maintains a hierarchical order, like from top to bottom, like this, or like this, where one element will be connected to more than one elements. Like 0 is connected to 3 to 1 here, and 1 to 0, 2 here, and 2 to 1, 4, and 0 here, and all of this. Yeah, so graph data structure. In graph data structure, each node is called vertex and each vertex is connected to other vertices through edges. So this is a vertex and this is an edge. So I'm so sorry, this is a node. What each node is called a vertex. Okay, so yeah, node, this is a node and we also call it as vertex, and this vertex is connected to other nodes using these edges. We call these edges and these elements as nodes or vertices. You can have a look at them for a minute and then we'll continue. Moving on to next type of nonlinear data structure, we have tree data structure here. So similar to a graph, tree is also a collection of nodes and edges. So coming to tree, we refer these vertices as nodes, or we call it root node. The first node is always called a root node, and then these are referred to as branches, and then the last nodes are referred as leaf nodes when we deal with trees. So it is similar to a graph. It is also a collection of nodes and edges. They are root nodes, leaf nodes, or you can also call it a parent node and child nodes, and these are called branches. So, however, in tree data structure, it can be one edge between two vertices, like between uh, two vertices or two nodes. There is only one branch or edge. So you take an example of these two nodes. We have only one branch between them. But when you take this, they have more than one connection. So this is all about tree and graph data structures. Yeah, you can have a look at it. These are some differences about linear and non-linear data structure. Everyone can have a look at them for some time. Yes, I hope everyone might have gone through that. So in linear data structure, the elements are arranged in a sequential order, whereas here we arrange the elements in a hierarchical manner rather than continuous memory blocks. We have hierarchical structures. And then coming to linear data structures, all items are present on single layer and the data items are present at different layers. So we have a single layer in linear data structures and here we have different layers. So linear data structures can be traversed on a single run. That is, if we start from first element, we can traverse all the elements sequentially in a single path. So in a linear run, we can go through what is traversing, go through each and every element. So we can go through each and every element in linear data structure within a single run, whereas here it takes multiple runs. That is, if we start from first element, it might not be possible to travel all the elements in a single pass. So we might require more than one pass. So coming to linear data structure, as we have learned, it does not cope up well with complex data. So when data or problems become complex, they cannot be used. They are not efficient basically. And then coming to here, different structures utilize memory in different efficient ways. Coming to the time complexity in linear data structure, it increases with the size of the data. So whenever the data increases, its time complexity increases. Like, so that's why it will not be efficient when data becomes complex. Coming to non-linear data structures, the time complexity remains same throughout the problem, throughout the process of solving the problem. So, what are the different examples of linear data structure? As we have seen, we have gone through arrays, linked list, stack, and queue are the data structure. And then we have tree, graphs, maps, hashings, and all in non-linear type of data structures. This is all about data structures. So we will also look at how are the things used in AI, like what are different data structures and algorithms that are used in AI. The first point, so why we use data structures and algorithms in AI. So it is efficient to store the data. So as we have dealt, it is efficient to store the data and modify or retrieve the data whenever it is necessary. So another thing, it allows graph-based representation, tree-based decision making, and then efficient searching and sorting algorithms. And under algorithms, we have search algorithms, sorting algorithms. We have neural network implementation. I think I have mentioned about all of these algorithms yesterday. In AI, we use various search algorithms, and under search, we have informed search and uninformed search algorithm. We have sorting algorithms. We have machine learning algorithms, deep learning algorithms. So deep learning and neural network implementation are all same. And dynamic data handling with queues and stacks. So dynamic programming can be easily done by using queue and stack data structures. So we have dealt with all of these things. And now we can look in depth. So I will share the link for the course within a minute now. And then yesterday, those who were not able to do that, and those who were not present, you can have a look at that. And then I'll continue with the class. Give me a minute or two. I'll share the link. Guys, whoever did not enroll or who were not present yesterday, please enroll yourself. And after some time, I'll give you time to complete this. You can focus on that. Yeah, so let us see what are data structures and algorithms in AI, and then we will end. Like, I'll give you guys time to complete that. Yeah, I hope my screen is visible. So yeah, let us continue. So it is useful in many ways. So what data structures and algorithms are useful in AI by many ways. So what is this efficient data storage and retrieval? So AI and ML models rely on data sets. I hope everyone's aware of what data sets are. So they rely on large data sets for training of data. So it makes use of arrays, linked list, and hash tables, which play a major role in storing and retrieving the data. So as we have dealt, like why arrays and linked lists are useful, they are useful to store and retrieve the data. So hash tables allow quick lookups, while linked list help us manage dynamic data. Like I have mentioned that we use them in dynamic programming. So proper data storage structures enhance the performance of model. So they reduce the amount of time taken, and then memory also. They reduces memory. So you guys can have a look on what this is all about. You can read it for a minute or two probably. So yeah, coming to graph-based representation. In many AI applications, so it might be any kind of analysis, recommendation systems, or while dealing with natural language processing. So they all rely on graphs to represent the relationship between various entities. We use graphs So, graph data structures, which contains nodes and edges, enables algorithms and knowledge graphs, uh, page rank. So, don't worry, these are all not important. So, it enables various algorithms, like it includes various algorithms that help us to perform the task efficiently. So, graph neural networks, it is also a kind of algorithm that is used in deep learning. So, GNNs further leverage this structure for deep learning applications. So, yeah, you can read this. So, the next thing is tree structures for decision making. So, decision trees, binary trees, B trees, these are all various types of trees that are used. We probably use mostly in machine learning. So, these trees, we also have heap trees, sort tree. We have various kinds of trees. These are used for classification and regression tasks. So CART, CART tasks. I hope everyone's aware of this. So, like algorithms such as decision trees, random forest, extreme gradient boosting, XG boost, that is gradient boosting trees. These all rely on tree-based data structures. So what do they do? They split the data into meaningful parts, where the first one represents uh, the root node and the following represents the child nodes or subnodes. So these are mainly used to make predictions. So they make predictions interpretable, that is understandable and efficient. So tree data structures are also used in various applications like autocomplete and text search. So coming to the next one, so we use them for efficient searching and sorting. So AI models require fast searching and sorting of data. So it is crucial for nearest neighbor algorithm. So KNN, I hope everyone is familiar with this algorithm. So it is a type of clustering algorithm. So data structures like heaps that are used in priority queues and trees and hash maps, they improve the data access speeds. Okay, so they improve speed because they have indexes. So they can be easily accessed through index. So the these kind of tree structures that accelerate nearest neighbor searches, they are often used in image recognition and anomaly detection. So in various AI algorithms we use image recognition and anomaly detection. So we use those algorithms to recognize the images and detection of anomalies. So they help a lot. You can have a look at this for some time. Read. So now, as we have seen through machine learning in data structures and algorithms, usage of ML and AI, now we will also look at neural network implementation. So neural network is just an algorithm that is used in deep learning. So deep learning models such as CNNs and RNNs, those are deep learning algorithms. So they heavily rely on matrices and tensors for computations. Okay, so it all includes computations, calculating weights and all. So tensor structures enable efficient operations. So matrix operations like dot products, convolutions, transformations, and all of them. So they are mainly used in back propagation and gradient descent optimization. So these are all the parameters that are used in deep learning, optimization, regularization, and all of them. So several libraries like TensorFlow, PyTorch, these are also optimized operations that are used to improve the computational efficiency in deep learning models. I hope there's no confusion. So there's nothing to worry. You can have a look at it. So first I'll explain and let you guys know. So dynamic programming includes queues and stacks, right? So dynamic data handling with queues and stacks. So AI applications that deal with real-time data processing. What are they? Chatbots like our Chat GPT, Alexa, and all of them. So such as chatbots, reinforcement learning, robotics, they all require handling sequential handling of operations. So for them, operations have to be sequentially handled. Like whenever you talk to Chat GPT, the operations should be sequential, right? So when I give it a prompt or when I ask it a question, after two more mm, after two more chances, it shouldn't give me the answer, right? So after immediately I post a question, it should give me the answer. So it should be sequential. The operation should be sequential. So queues help manage task scheduling, uh, ensuring data is processed in order. So for these, we use queues so that the data will be sequentially processed. So what do? They help us manage the task by scheduling them. Like after this operation, this has to be performed, and then after this operation, the next one has to be performed. So whenever, if you take an example of Chat GPT, I'll ask it a question. So explain me what is AI. It then schedules the task. So as after this question, it has to immediately give the answer within some time. And then ensuring data is processed in order. While stacks, what what do stacks do? They assist in managing recursive function calls, such as DFS, BFS, and all of them. Breadth first search and depth first search. So stacks manage recursive function calls, whereas queues, what do? They help manage the task in a sequential order. Yeah, now you can have a look at them. I hope there are no queries. If there are any, please let me know. And then after this, I'll give you, after you guys are done reading this, I'll again give you time to complete the course. So yes, I hope everyone have gone through that. So you can now complete your course. You can work on that. I'll give you guys time. You can do that now. This is it for today's class. You can continue with this course now.
So not only introduction part, you'll get others too. Try doing it again. If you face issue, there might be some technical problem. And regarding attendance, we don't have any specific links. It will be automatically taken if you are present for the sorry, if you are present for the whole 2 hours, it will automatically be taken. So okay, thank you everyone.